Good afternoon, everybody. Today I am giving a brief overview to prepare for the examination on the topic of Laplace transformation. Now, what is Laplace transformation? Laplace transformation is nothing but the improper integration. So, what is the improper integration? Suppose ft be a function. This is a ft be a function of t. Then the Laplace transformation of ft, this is equal to the improper integration 0 to infinity e to the power minus st ft dt. Okay, so this is the Laplace transformation of the function ft. So this is nothing but the integration. Already we have learned the integration in HS. And what is the main thing? That this is a improper integration, because at the point infinity it is undefined. Okay, so how we can deal it? This is equal to, now since at the point infinity the function is undefined, so we are considering a equal to capital infinity and then taking limit capital A tending to infinity e to the power minus st ft dt. Now if ft is a exponential function, then again we are putting this value and we are getting only one function, exponential function, and we are doing the integration. In ft is different function, then we will do the bypass integration. And after doing integration, we are getting the function like this, capital A tending to infinity, we are getting the function, and then we are putting the value, the upper value and lower value 0 to a, and then directly we are putting a equal to infinity directly, because infinity we cannot put infinity. So after putting a equal to infinity, what will be the value? We will put that value and we will get the function of s. And what is s? S is the parameter. It may be complex or it may be real. So what we are getting, Laplace of the function ft, this becomes a function of s, because we are doing the integration on with respect to t. So that's why ultimately we are getting the function of s. Now come to the example. Suppose ft is equal to 1. So I am doing some example. So what is the Laplace of ft? The Laplace of ft, this is equal to integration 0 to infinity e to the power minus st ft dt. So therefore Laplace of 1, so ft becomes 1, integration 0 to infinity e to the power minus st into 1 dt. So this is basically the integration of e to the power minus st. So we have to consider infinity equal to a and then putting a limit a tending to infinity. A tending to infinity, integration 0 to infinity e to the power 0 to capital A e to the power minus st dt. Now what is the integration of e to the power minus st? This is equal to limit capital A tending to infinity e to the power minus st divided by minus s, and we are putting the range 0 to capital A. So this becomes limit capital A tending to infinity. Then if we are putting t equal to capital A, we are getting e to the power minus s capital A by minus s minus sub minus this, that is plus e to the something to the power 0, putting t equal to 0. So we are getting 1, something to the power 0 equal to 1 by s. Okay, now we will put the a equal to infinity. So if we put a equal to infinity, so e to the power minus infinity, it becomes e to the power minus s infinity, so e to the power infinity. So what is the value of e to the power infinity? This is equal to 1 by e to the power infinity. So this is equal to 0. So that's why we are putting 0 plus 1 by s. So therefore we are getting Laplace of 1, this is equal to 1 by s. So we are getting one formula, but it itself is a sum. So if it is if in the question it is asked to find the Laplace transformation of 1, then we have to do this integration and we have to find the value. Now here we are showing here e to the power minus infinity. You cannot put the value e to the power minus infinity. You can put the value, if we put infinity, then what will be the value we can put it here. Okay. So we are getting Laplace transformation of 1 equal to 1 by s. Now what is the second function? Suppose next example, example 2. So suppose ft, this is equal to t to the power. It is a very important question. So many times it comes to the examination. So we have to find the Laplace transformation of t to the power n. So what is the Laplace transformation of t to the power n? This is equal to integration 0 to infinity e to the power minus st into t to the power n dt. Okay, so now already we have told that how we will deal the improper integration if at the point either in the lower limit or in the upper limit, if the function is undefined, then considering that point as capital A and then taking limit capital A tending to infinity. So whenever you are doing this sum in the examination, always do it in that procedure. Already we have shown it in the previous example, but now I am not considering it capital A, I am doing it directly. So this is equal to, so we are considering, suppose we are considering it capital In. Why In? Because this is the integration and t to the power n. So we are giving the name of this as a In. So what is In? So In is equal to integration 0 to infinity e to the power minus st into t to the power n dt. Now we have to use the by parts. Now which function we will integrate and which function we have to differentiate. Now here always remember the technique that the integration of which function is easy, we will integrate that function, and the differentiation of which function is easy, we will differentiate that function. There is another technique, that is islet. But suppose you don't know what is islet. So always remember that differentiation of which function is easy, you differentiate that function, and integration of which function is easy, you integrate that function. But here both the function e to the power minus st, the differentiation and integration both are easy, and here t to the power n, the differentiation and integration both are also easy. Now the question is, we will do the differentiation of which function and we will do the integration of which function. If we integrate t to the power n, then what will be the value? T to the power n plus 1 by n plus 1. So the power is increasing. If the power is increasing, then this integration will never end. But if we differentiate, then what will be the value? N into t to the power n minus 1. So power is decreasing. So after some times, t to the power, it will be t to the power 0, and very easily we can get the integration of e to the power minus st. So it is very easy to do the differentiation of t to the power n. That's why here we are doing the differentiation of t to the power n and integration of e to the power minus st. Now we are using the by parts formula. So what is the technique? At first we are using the first function integration, the first function, that is e to the power minus st. So this is equal to t to the power n into e to the power minus st divided by minus s, because we are doing the integration with respect to t and putting the 0 to infinity, then minus. Then what is the technique? Integration of e to the power minus st. So integration of e to the power minus st dt. Then differentiation of t to the power n. Then differentiation of t to the power n. So differentiation of ddt of t to the power n, and then whole integration with respect to t within the range 0 to infinity. So we are getting, now we are putting infinity, So if we are putting infinity, t equal to infinity, so it becomes e to the power minus infinity. Again, e to the power minus infinity means 1 by e to the power infinity. So it becomes 0. So if we put infinity, it becomes 0. Then minus of minus, that is plus. If we put t equal to 0, so 0 to the power n, that is 0, 0 into something, that is equal to 0, so it becomes 0. So if we put infinity, we are getting 0. If we put 0, we are getting also 0. Then minus integration 0 to infinity. Now what is the integration of e to the power minus st? E to the power minus st divided by minus s into, what is the differentiation of t to the power n? N into t to the power n minus 1, and then whole integration, that is dt. Okay, clear? Now what is the value we are getting? Now s is constant, it is not dependent on t, and n is also not dependent on t. So we can take n and s outside of the integration, and then this minus and this minus, it becomes plus. So we are getting n by s integration 0 to infinity e to the power minus st into t to the power n minus 1 dt. So already we consider in. What is in? In is equal to integration 0 to infinity e to the power minus st t to the power n dt. Now here we are getting another integration, that is integration 0 to infinity e to the power minus st t to the power n minus n. So the difference is only in the power, that is n minus 1. So if we consider this integration as in, so we can write this integration as in minus 1. So it becomes n by s in minus 1. We can get the name of this as in minus 1. So what we are getting? We are getting the relation, that is in is equal to n by s in minus 1. Now this relation, using this relation, we will find the value of the integration, because I don't know what is the value of it. So I don't know how many times we have to do the integration. So that's why by using this formula, we will find the next value of in minus 1, and when we are getting the value of in minus 1, we will get in minus 2. Again we are getting the in minus 2 value of in minus 2, and so on. So what is the value? This formula is called the reduction formula. It is a very useful technique to find the integration. Okay, now what is in minus 1? If in place of n we are putting n minus 1, so here in the right hand side also in place of n we are putting n minus 1, so it becomes n minus 1 by s I. If we put n minus 1 in place of n, it becomes n minus 1 minus 1. This is equal to n minus 1 by s into I n minus 2. Clear? So now we will get in minus 2, in minus 2. This becomes, again in place of n, we are putting n minus 2. So this becomes n minus 2 by s I n minus 3. So in this way, we will run the process. So that means the value of n is decreasing. So n minus 1, at first it was n minus 1, then it becomes n minus 2, then it becomes n minus 3. So gradually the value of n is decreasing. So after some times n will be equal to 1. N will be equal to 1. Because it is gradually increasing, n minus 3, then it will be n minus 4, then it will be n minus 5, and so on. And after some time it will be n minus 1. And what is the value of n minus 1? N cancel, so it becomes 1. So after some time we are getting I1. So when we are getting I1, that is n equal to 1. So in the right hand side also we are putting n equal to 1. So we are getting 1 by s I0. Now we will find the value very easily. We will find the value of I0. So I0 is equal to, what is in? Integration 0 to infinity e to the power minus st into t to the power n. So I0 means in place of n we are putting 0. So t to the power 0 dt. This is equal to integration 0 to infinity e to the power minus st into 1 dt. So this is nothing but the Laplace transformation of 1, or very easily you can do the integration. So I am not doing the integration again, because already we have shown that this is the Laplace transformation of 1. And what is the value of Laplace transformation of 1? This is equal to 1 by s. So we are getting So now we are putting the value of in. In is equal to integration 0 to infinity e to the power minus st into t to the power n dt. We have to find this value. This is equal to, we are getting, already we are getting the formula in equal to this. So n by s I n minus 1. Now we are putting the value of n minus 1. So this is equal to n by s into, now we are getting, already we got the value of in minus 1. So what is in minus 1? The value of in minus 1 is equal to n minus 1 by s in minus 2. Okay, already we are getting this value n minus 1 by s in minus 2. So we will put this value. So n minus 1 by s I n minus 2. So in this way, again we are putting the value of I n minus 2. So n by s into n minus 1 by s into n minus 2 by s into n minus 3 by s, because we will gradually put the value, and at last after some times we are getting I1. Now already we have find the value of I1. So what is the value of I1? This is equal to n by s into n minus 1 by s into n minus 2 by s into n minus 3 by s into dot dot dot. I1 is equal to 1 by s into I0. 1 by s into 1 by s into I0. And again we are finding the value of I0. Now we will put the value of I0. I0 equal to 1 by s. So this becomes n into n minus 1 into n minus 2 into n minus 3 into dot dot into 1 divided by, how many s is in the denominator? There exists s to the power n. Why? Because n number of s is there. Because when it is 1, we are getting 1s. When it is 2, previous term is 2 by s. When it is 2, then again we are getting 1s. That means we are getting 2s. And when it is n, we are getting n number of s. So it becomes s to the power n. And again, what is the value of I0? I0 equal to 1 by s. So we are getting, in the numerator, what is the value? N into n minus 1 into n minus 2 into n minus 3 dot 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 up to 1. That means factorial n divided by s to the power n plus 1, because it is 1n and it is 1. So n plus 1. So s to the power n plus 1. So what we are getting? Therefore, in equal to this. And what is in? This is the Laplace transformation of t to the power n. So we are getting the formula Laplace transformation of t to the power n. Okay. So Laplace transformation of t to the power n is equal to factorial n by s to the power n plus 1. Now if sometimes in the question it is, so it is a very important question also. Otherwise, we have to remember this formula. A Laplace transformation of t to the power n equal to factorial n divided by s to the power n plus 1. Very easily you can find the value. Now, Laplace transformation of t. What is the value? What is the value of n here? Here the value of n is 1. So this becomes factorial 1 divided by s to the power 1 plus 1. This is equal to 1 by s square. Okay. What is Laplace transformation of t square? This is equal to 1 factorial 2 divided by s to the power 3. Okay. So in the numerator it is factorial 2. So here the power of s will be 1 plus. Okay. Now here Laplace transformation of t is equal to, we are getting 1 by s square. Okay. Similarly, we can get the value. Now there is a very interesting thing, that is Laplace transformation of t. This is equal to 1 by s square. Now Laplace transformation of t can be written t into 1, that is equal to 1 by s square. Now, what is the Laplace transformation of 1? Laplace transformation of 1, this is equal to 1 by s. So, if 1 is multiplied by t, then the denominator term becomes whole square. Clear? So, whenever, always remember, if the denominator term is whole square, then remember that the function is multiplied by t. always remember if the denominator is there is a whole square in the denominator, then always remember that the function ft is multiplied by t. So here 1 is multiplied by t. That's why it becomes 1 by s square. And what is 1 by s? 1 by s is the Laplace transformation of 1. So when 1 is multiplied by t, it becomes 1 by s square. Clear? Now we will find the Laplace transformation of sin t. It is a very important thing. That is, ft becomes sin t. How we can get the sin omega t? So I am giving the general formula omega. Omega may be 1. If omega equal to 1, then it becomes sin t. If omega equal to 2, then it becomes sin 2t. Okay? We can get Laplace transformation of sin omega t, Laplace transformation of cos omega t, Laplace transformation of sin hyperbolic omega t, as well as Laplace transformation of cos hyperbolic omega t. Now, always we will try to write the function in the form of e to the power something. So how we can write sin omega t? Already we know that. Now, if you forget this one, then write it in the rough. What is the formula? E to the power I theta. This is equal to cos theta plus I sin theta. Okay. So this is the formula. We know it very much. That is cos theta plus I sin theta. Now, what is e to the power minus I theta? Minus I theta equal to cos theta minus I sin theta. Okay. Now, if we subtract these two, then cos theta will be cancelled. E to the power I theta minus e to the power minus I theta. This is equal to cos theta plus I sin theta minus cos theta minus I sin theta. So cos theta cancel. I sin theta plus I sin theta, we are getting 2I sin theta. So sin theta becomes e to the power I theta minus e to the power minus I theta divided by 2I. Okay, clear? This becomes sin theta. Now, if we add these two, then sin theta will be cancelled, and 2 cos theta will be equal to e to the power I theta plus e to the power minus I theta. So cos theta becomes e to the power I theta plus e to the power minus I theta divided by 2. Okay. So sin theta and cos theta is equal to this. We are getting this value. Now, very interestingly, we can get the sin hyperbolic theta. What is the formula of sin hyperbolic theta? This is equal to, just omitting I, you will get the formula of sin hyperbolic theta. So it becomes e to the power theta minus e to the power minus theta. I am omitting I divided by 2, and cos hyperbolic theta is equal to e to the power theta plus e to the power minus theta divided by 2. So if we add, we will get cos. If we subtract, we will get sin. If normally there is a I sin theta, and when you are finding hyperbolic function, then no I is there. Now, very easily, we can find the Laplace transformation of sin theta. Now, before going to this, I am showing you the Laplace transformation of another function, that is e to the power at. So, if we know the formula, then very easily we can find the value of Laplace transformation of sin omega t after writing sin omega t in terms of e to the power I theta. Okay, so this is equal to integration 0 to infinity e to the power minus st into e to the power at, because ft equal to e to the power at dt. This is equal to integration 0 to infinity e to the power. Now it can be written in the form of e to the power a minus s whole into t dt. But we will not write a minus s. We will write minus s minus a t dt. Why? Because it is of this form e to the power minus st. So here consider this is as s. So what is the Laplace of 1? The Laplace of 1 is integration 0 to infinity e to the power minus st into 1 dt. So if we, in place of s, what is the difference? In place of s, this is s minus a. Here also it is what? In place of s, this is s minus a. So as like as before, if we do the integration, ultimately we will get the value of 1 by s minus a. So we are getting Laplace transformation of e to the power at. This is equal to 1 by s minus a. Okay, clear? Now we will find the Laplace transformation. Very easily, in the same way, we will get the value of Laplace transformation of e to the power minus at. And what is the value? 1 by s plus a. In the same way, if we do the integration, we will get it. So what is the formula? If it is e to the power at, that is plus a, then it becomes 1 by s minus a. And if it is e to the power minus at minus a, it becomes plus. So if it is plus a, it becomes minus. If it is minus, then it becomes plus. Okay. Now we will use this formula to find the value of Laplace transformation of sine omega t. Laplace transformation of sine omega t. This is equal to Laplace transformation. What is sine omega t? So you have theta equal to t over I theta. So omega t, in place of theta we are putting omega t e to the power I omega t minus. If we do the minus, we are getting sine e to the power minus I omega t divided by 2i. Okay. Now 2i is constant. 1 by 2i. Now by linear property, what we can do? This is the Laplace transformation of e to the power I omega t minus Laplace transformation of e to the power minus I omega t. Now already we are getting the formula Laplace transform e to the power at equal to 1 by s minus. If the power of e is plus, then it is minus. If the power of e is minus, then it is plus. So here it is e power of e is plus. So 1 by 2i 1 by s minus I omega. Okay, then it is minus. It is minus, so we are getting plus 1 by s plus I omega. Now simplifying this function, 1 by 2i into taking the LCM, s minus I omega into s plus I omega. So this is s plus I omega minus s minus I omega. So here, since it is minus, so always use brackets here. Otherwise, what will happen? In the examination hall, you will change the sign of the first term and you will forget to change the sign of the second term. So that's why you always use the bracket. So now this is s and minus s cancel. I omega minus minus plus I omega. So we are getting 1 by 2i omega divided by s minus I omega, s plus I omega. That is a plus b into a minus b. That is s square minus I omega whole square. So this is 2i cancel. So we are getting omega divided by s square. I square means minus 1. Then again minus a plus omega square. So we are getting therefore Laplace transformation of sine omega t. This is equal to omega divided by s square plus omega square. Now very easily in the same way we can get the value of the Laplace transformation of cos omega t. And what will be the formula? In the same way we will do the integration and we will get the value. What will be the value? S by s square plus omega square. So when you are finding Laplace transformation of cos omega t, it is s by s square plus omega square, and when you are finding Laplace transformation of sin omega t, it becomes omega by s square plus omega square. Now the question is how we can remember. Sometimes or in the examination hall we will be in person, then we will forget that in place when we are finding the sine we will put it here s, and when we are finding cos we put it here omega. Now how we can remember? I am remembering in this way, that if we extend the term cos, so extend the term cos, so s will be pronounced longer. So it is s by s square plus omega square. So if s is in cos, then omega will be in sine. Clear? Now in the same way, we can find the Laplace transformation of sine hyperbolic omega t. So this is equal to, again, the numerator will be same, omega divided by s square minus omega square. Only the difference is in the denominator, that is minus. When you are finding the normal Laplace of normal sine omega t, then denominator is plus. When you are finding sine Laplace of sine hyperbolic omega t, the denominator becomes minus. So s square minus omega square. So numerator is same. So similarly, Laplace of cos hyperbolic omega t, this is equal to, again, numerator will be same, s by s square minus omega square. So these are the basic formula, or sometimes this may also come in the examination to find the value. So what we are getting today? Today we are getting the formula Laplace transformation of 1. This is equal to 1 by s. Laplace transformation of e to the power at. This is equal to 1 by s minus a. Laplace transformation of e to the power minus at. We are getting 1 by s plus a. Laplace transformation of sine omega t, this is equal to omega divided by s square plus omega square. Laplace transformation of cos omega t, this is equal to s divided by s square plus omega square. Laplace transformation of sine hyperbolic omega t, this is equal to omega divided by s square minus omega square. Laplace transformation of cos hyperbolic omega t, this is equal to s divided by s square minus omega square. Laplace transformation is very important. T to the power n, this is equal to factorial n divided by s to the power n plus 1. So always we have to remember all these formula. If we forget this formula, then it will be very difficult to find the Laplace of any other function. So any function can be written either in terms of e, or if it cannot be written in terms of e, then either this will be sin t, cos t, like this. So these are very important formula to find the Laplace transformation. Okay. So thank you. This is for today's learning. Now in the next day, we will go to the several formula when it is multiplied by t or divided by t, Laplace transformation of the derivative, Laplace transformation of integration, we will find the several formula. Thank you.